So this series is part of the series that I put under challenging series. It's a little bit complicated, but there is a beautiful lesson to be learned from this one. So again, let's start first. They are asking us for conversions or diversions of sigma minus 1 to the n over square root of n plus minus 1 to the n. So of course here a mistake not to be made. It's very easy to see that minus 1 to the n over square root of n plus minus 1 to the n, okay, this is equivalent to, because at the bottom the square root of n takes over the minus 1 to the n for n greater than, for example, I'm sorry, we cannot take 2 because we will have a problem when n is equal to 1. So anyway, this will be when n is large. Okay, and we know that the series minus 1 to the n over square root of n convergent by the alternating series test, AST. Okay, and therefore we would love to conclude, so this is the mistake, this is something that's wrong to do, is to claim that sigma of minus 1 to the n over square root of n plus minus 1 to the n from 2 to infinity is convergent by the limit test. We would love to do that. The problem is, why is this not true? Because the limit test is only valid for positive series, and this series here is not. Neither one of them is positive. They are alternating anyway. Sign. So as you can see, we cannot use the limit test. So this argument is wrong. So we have to use something else. The idea behind this one, one way to see it, first, and then we'll see how to prove it. Okay, so first, we use the geometric series. We know that 1 over 1 plus x is 1 plus x squared plus x cubed, I'm sorry, minus. Okay, so this is 1 minus x plus x squared minus x cubed, etc. when absolute value of x is less than 1. Okay, this is just the geometric series. And now this will tell us that 1 plus x, I'm sorry, we can use this and we'll get that minus 1 to the n over square root of n, okay, is equal. So here n has to be bigger than, let's say, 2, for example, and then we can use this geometric sequence. So we're going to have minus 1 to the n over square root of n plus minus 1 to the n over square root of n squared plus the rest that comes would be tinier than 1 over n. Okay? So now, if I multiply by minus 1 to the n over square root of n, everything, this will give me minus 1 to the n over square root of n minus 1 over n, and then plus what we have here is 1 over n, so it's going to be minus 1 to the n over n square root of n plus something very small compared to n square root of n. Okay, so this tells me, because this expression here is the original series, which is minus 1 to the n over square root of n plus minus 1 to the n. Okay, so we see that when n is large, this behaves like minus 1 to the n square root of n minus 1 over n plus minus 1 to the n over n square root of n plus something that is tiny compared to n square root of n. Okay? So what I'm going to do now, knowing this is just the research. So now what I'm going to do, I'm going to introduce a new series, which is minus 1 to the n, our series, and I'm going to take this to the other side. So this will give me, not all of it, just this one, okay? Because the remaining part is convergent using the p-test, absolute convergence. So this is the part that will be a source of trouble. So we take it out. So this will give me minus 1 to the n over square root of n plus 1 over n. So let us study now this new series, sigma of, so we want to study now sigma of xn from 1 to infinity. Okay? So we have some algebra to do. Sorry, from 2. Xn equal, so we have minus 1 to the n over plus minus 1 to the n, and then here minus n minus 1 to the n minus square root of n over n square root of n. And now this gives me xn equal minus 1 to the n square root of n minus square root of n plus minus 1 to the n times minus 1 to the n minus square root of n over n square root of n times square root of n plus minus 1 to the n. So xn equal, and we have to develop all this, minus 1 to the n square root of n minus, so we have minus 1 to the n square root of n minus square root of n times square root of n, that's n, plus minus 1 to the n times minus 1 to the n times n minus 1 to the n times square root of n over n square root of n times square root of n plus minus 1 to the n. So xn, now we start doing some algebra. So we see here that we have, let's develop it because we have the minus here. So minus 1 to the n square root of n minus 1 to the n square root of n plus n, and here we have minus, and as you can see, minus 1 to the n times minus 1 to the n, that's the square, that's 1 times n, and then we have minus with minus, that's plus minus 1 to the n square root of n over n square root of n times square root of n plus minus 1 to the n. So this gives me xn, so this is equal, and now we start cancelling some. So we have the n with the n, we have this with this, and we're going to find minus 1 to the n square root of n over n square root of n times square root of n plus minus 1 to the n. So cancel the square root of n, and this will give me xn equal minus 1 to the n over n times square root of n plus minus 1 to the n. So now, if we take the absolute value of this one, the reason is because when n is large, this term here is gonna go away. So you have basically n squared root of n at the bottom. So that's why it's n to the power 3 half. We can use the p-test and we will be okay. Therefore here it's n absolute value is equal to 1 over n times square root of n plus minus 1 to the n. Okay? And this is for n greater than 2. Okay? For n greater than 2, it's going to be positive. And this is equivalent to 1 over n square root of n for n large. So now we're dealing with positive series. So since 1 over n square root of n is equal to 1 over n to the power 3 half, and 3 half is bigger than 1, the p-series tells me, and the p-series test tells me that sigma of xn is convergent. Here, of course, I'm using by p-test combined with the limit test. So this series here is convergent, which means that sigma of xn is absolutely convergent. So now, what does it mean now? Let's go back to our xn. So what did we find? Okay, so we found that here xn is, we have this one, which is convergent by the AST. So xn plus, so again, let's go back and write. So it's going to be, so what is xn? So we have xn equal minus 1 to the n over square root of n plus minus 1 to the n, okay, minus 1 to the n over square root of n plus 1 over n. So if I take this one here to the other side because it's convergent, I will get xn plus minus 1 to the n over square root of n. This series is convergent. Okay, so this is convergent, and if I take the 1 over n to the other side, okay, this will be minus 1 to the n over square root of n plus minus 1 to the n. Okay, so as you can see now, let's look at it. This one here is absolutely convergent. This one here is conditionally convergent by the alternating series test. And this one is divergent. So the total will be divergent. So the series, one is absolutely convergent, one is convergent, therefore it's convergent, plus one which is divergent, therefore the total is divergent. So this series is divergent.